Now, we were just looking at this table up here, and hardly ever, if I have 0.57 moles of this, am I going to give you exactly 0.19 moles of this so that we can make exactly 0.38 moles of this? A lot of the time, you have one of these, you have more than you need. And so we're going to have to look at what is called the limiting reactant. Okay, so what happens when you have two specific amounts are for two reactants? Okay, for example, looking at this equation, say I gave you a certain amount of nitrogen and a certain amount of hydrogen, maybe it's not a 1-to-3 ratio, then how much stuff do I make? Okay, so I'm going to use an analogy first because this is called limiting reactants. Okay, so it's like which reactant, because one of them, you always run out of one of them, is going to limit the amount of stuff you can make. Okay? So the reactant that runs out or that limits your amount of product is known as the limiting reactant. One is always going to be limiting and one is always going to be excess, unless for some crazy reason I gave you the exact amounts you need. Okay, so an analogy for this is say I'm putting bicycles together. Okay, bicycles meaning they need 2 wheels. I have 200 frames and 350 wheels. Well, you're like, well, if I give this, and I was like, how many bicycles can I make? Well, if I just look at the frames, I can make 400 bicycles. But if I just look at the wheels, well, I need 2 wheels for each one. I can only make 175 bicycles. So this limits the amount that I can make. My theoretical yield, or theoretically, if everything was great, I could only make 175 bicycles and I would have 25 excess frames. Okay, I did, if I'm making 175 bicycles, I obviously need 175 frames. So I did 200 minus 175 to get 25 excess. So using those chemical terms, the wheels were my limiting reactant, even though I had more wheels, but since I needed 2 wheels for every 1 frame, I'm going to run out of this first. So that's called my limiting reactant. So then the amount of stuff I can make, my product, is called my theoretical yield. So theoretically, it would yield 175 bicycles. And then the excess is how much of the other reactant, not my limiting reactant, is left over. And we can calculate all of these things with masses and moles of chemicals. Okay, so for example, we're going to look at a chemical level now. We're going to start with molecules, the small ones. Suppose a vessel or a container contains 10 molecules of H2 and 7 molecules of O2. How many water molecules are possible? So I'm going to look at this balanced equation. You're like, okay, I got 10 of these and I have 7 of these. Well, if I have 10 hydrogens, I only need half that many oxygens because this is a 2-to-1 ratio. So I only need 5 oxygens in order to make water because this is a 2-to-1 ratio. So I know I have 7 molecules of oxygen. I have plenty of oxygen. I only need 5 of them. So oxygen then is my excess reactant. That means hydrogen is my limiting reactant. Okay, you can probably also figure out your theoretical yield here. If I have 10 of these, this is a 2-to-2 or 1-to-1 ratio. That means I'm going to make 10 waters. So what does this look like? The red ones are your oxygen. So I have 1, 2, 3, 4, 5, 6, 7 oxygens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens or H2s. Okay, I know I'm going to run out of this because I need twice as many hydrogens as I do oxygens. So after the reaction happens, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 water molecules. And you'll notice I still have 2 oxygen molecules left over. Okay, so I made 10 waters and I have, that's my theoretical yield, and I have 2 O2s. Okay, so this works for all situations. You're going to have some of this and some of this. Well, how many can I make based on whichever one's going to run out first? And then I'm going to have some excess of something else left over. Okay, so this was the molecular level. You'll notice I didn't lose any atoms or anything. We're going to scale it up to a mole and a gram level. Now, there are really 2 ways of approaching these problems. Anytime you've got to like, how much stuff am I going to make? You can either use what's called a BCA table, and that's what I'm going to go through first, or you can use dimensional analysis, which is, we just kind of say stoichiometry. So go ahead and pause. You can use whichever method you find best or watch both and then decide.